Hello everyone. Today, we're going to discuss a topic of immense strategic importance, rare earth elements. These 17 metallic elements, despite their name, are not geologically rare, but their economic extraction and, crucially, their refining are incredibly complex. This complexity, combined with a deliberate, decades-long strategy by China, has led to Beijing establishing a near monopoly across the entire supply chain. This concentrated control grants China significant geopolitical and economic leverage, which it has demonstrably used, leading to global supply chain vulnerabilities and escalating international tensions. We'll explore why these elements are so vital, how China achieved its dominance, the profound implications of this control, and what the world is doing to mitigate these risks. First, let's understand what are rare earth elements and why these elements are so critical. Rare earth elements are a group of 17 metallic elements, including the 15 lanthanides, plus scandium and yttrium. They are typically soft, ductile, malleable, and have a silver-gray luster, oxidizing rapidly in air. While abundant in the Earth's crust, they are rarely found in large, concentrated deposits that are economically viable to mine. The true rarity lies in the difficulty and cost of extracting and refining them into usable forms. The unique properties of these elements make them foundational to nearly every modern high-tech industry and critical for national security. Rare earth elements form a crucial technological backbone, indispensable for various consumer electronics. They are vital for powerful magnets found in computers and cell phones and are critical components in touchscreens, with elements such as dysprosium, gadolinium, praseodymium, samarium, and neodymium being particularly important for these strong magnets. Beyond consumer devices, these elements also play a significant role in fiber optics and data centers. Furthermore, these elements are fundamental to the clean energy transition. The shift towards sustainable energy sources is heavily reliant on these elements. For instance, neodymium is crucial for the permanent magnets used in electric vehicle, EV, motors, and wind turbine generators. Cerium, neodymium, samarium, and praseodymium are essential for rechargeable batteries, and the demand for EV batteries alone saw a 25% increase in 2024. Projections indicate that renewable energy will generate 46% of global electricity by 2030, further underscoring the importance of elements in this sector. REEs are critical for defense and national security. They significantly enhance the performance of advanced surveillance, targeting, navigation, and weapon systems. These elements enable cutting-edge radar, sonar, laser guidance, communication, and propulsion technologies, finding applications in systems like the Patriot Missile Air Defense Systems radar, and in the radars of aircraft such as the F/A-18 Super Hornet and F-15X. Neodymium, praseodymium, and samarium are vital for the high-powered, compact magnets used in precision-guided munitions and unmanned aerial vehicles, UAV, making a secure supply chain a paramount national security priority. The demand for these elements has surged, with the market currently valued at $4.1 billion and projected to nearly triple to $9.9 billion by 2034. Experts estimate that by 2040, the world will need up to 7 times more of these materials. This escalating demand, coupled with a concentrated supply chain, inevitably leads to heightened market strain and geopolitical competition. China's leading role in the rare earth elements supply chain is a result of a calculated, long-term strategy. Starting in the late 1980s, China deliberately sold rare earths at significantly low prices. This tactic effectively eliminated competition by forcing the closure of mining operations in other nations, including the United States, thereby dismantling alternative supply chains and establishing China's current market dominance. China currently holds a near monopoly in the rare earth metals supply chain, especially in processing and refining. In 2024, China mined 69% of global rare earth ores, a share projected to drop to 51% by 2030, but still far exceeding other nations like the US at 11.5%. However, China's most significant control lies in its absolute dominance over refining, accounting for roughly 90% of global separation and metal refining in 2023. This includes producing 85% of refined light rare earth elements and a full 100% of refined heavy rare earth elements, effectively giving China an estimated 85% control of global processing capacity. This processing chokehold means that other countries mining rare earth ores remain reliant on China for their refinement into usable forms. China is unique in having a completely integrated supply chain for both heavy and light rare earths, encompassing extraction, separation, alloying, magnet production, and recycling. This holistic approach provides significant economies of scale, established infrastructure, and cost efficiencies that are exceedingly difficult for new entrants to overcome. China has consistently utilized its dominance in rare earth elements as a geopolitical tool. This strategy was evident in 2010 when it restricted elements exports to Japan, causing a massive price surge and alerting the global market. Again, during the 2019 to 2020 trade war with the US, China hinted at export restrictions, leveraging REEs as a bargaining chip. Most recently, in April 2025, new export restrictions on 7 specific REEs in retaliation to US tariffs immediately halted automotive production in the US, Europe, and Japan due to severe shortages. Beyond direct restrictions, China also coerces foreign firms into technology transfers through intrusive export license demands, aiming to acquire foreign technology and control manufacturing supply chains. This concentrated control grants China significant power for economic warfare and geopolitical pressure without direct military action. China's strategy includes deliberately flooding the market with excess supply of critical minerals, driving down prices to levels that make mining operations in countries like the US and Australia economically unviable, often forcing them to shut down. The concentration of the REE supply chain in China directly impacts global manufacturing and technological development. Supply chain bottlenecks lead to instability and unpredictability, causing production halts for manufacturers. Economic coercion, through price manipulation, stifles the development of diversified supply chains, making it harder for the global market to meet skyrocketing demand. This impacts the cost-effectiveness and scalability of advanced technologies and can hinder innovation outside of China's control. To combat vulnerabilities in the rare earth supply chain, countries are actively diversifying. The European Union's 2024 Critical Raw Materials Act aims for 2030 benchmarks: 10% domestic extraction, 40% domestic processing, 25% domestic recycling, and limiting single-country reliance to 65%. The United States is funding initiatives like the Earth MRI, subsidizing processing plants, example, Linas in Texas, and seeing new domestic mining projects like Ramaco Resources Brook Mine. Australia is securing its critical mineral assets. India is rapidly emerging as a key player in rare earth elements. Holding the world's third-largest reserves, the nation is investing heavily with a 1,345 crore rupees scheme for domestic magnet production and the 16,300 crore rupees National Critical Mineral Mission. India also boasts its first integrated magnet recycling ecosystem in Hyderabad and is seeing increased involvement from both state-owned IREL, which is prioritizing domestic supply, and major private sector players. With 13 new elements exploration blocks auctioned, India is aggressively pursuing strategic autonomy in critical minerals. Long-term strategies for rare earth elements focus on alternative materials and robust recycling infrastructure. Scientists are developing substitutes like iron nitride and manganese aluminum carbide (MnAlC) for magnets, aiming to reduce reliance on REEs. While promising, scaling these alternatives for commercial use presents challenges. Simultaneously, recycling efforts are underway to recover these elements from e-waste, EVs, and wind turbines, with the EU targeting 25% of its critical material consumption from domestic recycling by 2030. These initiatives aim to lessen the demand for new extraction and reduce geopolitical risks, fostering a more circular and resilient rare earth economy. Thanks for watching. Don't forget to like, share, comments, and subscribe for more incredible tech videos.